All right, hello, welcome back to we're in this episode or continuing on this episode of drawing an image onto our window. And let's try and get this done quickly. So I'm going to quickly hide my camera so we can get right straight back into coding. And today we're going to be adding a texture file. So we're going to add a texture. Since we want to load in images, we're going to need a class to handle that, and our class name is going to be texture. And a few things that we'll need to be including is we're going to need GL generic functions, or generic variables. And let's go ahead and start building our class. Let me zoom in here. Call that class texture. And inside of our class texture, we're going to have a few different things. For one, we're going to have an ID, so how we're going to grab that texture from where it's being loaded from using STB. And a few other things that we're going to need. Let's make these public. We're going to need the image width and height. So let's go ahead and define that, width, height. Pretty self-explanatory for that. The next thing is we're going to have to figure out how the image is formatted, both in our program and how it's formatted outside of our program. So we're going to be defining those using GLUint internal format. So that's generally like how that's used is like say you have transparency in an image and it's handled. You want it to be handled like outside of the image. Maybe it has transparency, but inside of your program, you don't really care about transparency, and you want to just set up the internal formatting so that it's flat and not with any like excess pixels or any transparency pixels. So you just have to define these. This is not really that useful. We're going to probably be defining these both as RGBA, as we want them to be both classified as having transparency pixels both inside and outside of our program. The next thing is we're going to need a few configuration variables. So wrap _s, and the wrap function, that is just like how textures are handled outside of the image. So images are generally unprecise in terms of like grabbing them or like capturing like different components of them. So wrap S and T are used to handle once like you're grabbing information outside of the image data, so that you're not you don't like crash the program and draw something that you're not supposed to. The next thing is the filter. So filter min and filter mag. And this is how it handles scaling, I believe. And filter mag. So if you are scaling your image outside of what its actual dimensions are, filter min and filter mag help you handle how that's going to look like. All right, so those are your basic variables. The next thing that we're going to need to define, the texture constructor. So let's go ahead and define a few things for that. GLUint internal format. Actually, I guess the only thing we're really going to be dealing with now, let's just define the regular constructor for now. We could have more, and maybe I'll just copy and paste the other options that I have written down here. These two, and we'll kind of go over. We're just setting up like pretty basic constructors here, and we're kind of short on time. I don't want to waste your guys' time with just writing out code that isn't really that interesting, or anything that there's nothing to really talk about there. The next two functions that we're going to be dealing with are load and bind. So the load function, pretty self-explanatory. We're just loading the image into our program so we can utilize it. And bind makes it so that we're ready to render with it. So we're ready to draw with it. So these two functions are useful for rendering. And let's go ahead and define these functions here. Function signature was copied to clipboard. Interesting. Let's go ahead and create the CPP file then. Oh, this is still in shaders. That makes sense. Let's go ahead and create texture.cpp. Oh, there's two different ones. I don't know which one it is. Let's just delete both of them. And, oh, I kind of forgot to fix this in the last episode, but let's go ahead and fix this again. We'll have to go to our resources, shader, and move this. So cut and paste. And then we'll delete this. I guess save, that's fine. And we'll read add it here. All right, so let's go ahead and I'm going to just copy and paste a few different things, but let's set up our includes first. So we're going to need texture.h, obviously. So that's where all of our functions are located. In the next bit, we're going to need to define stb image implementation. So that's just going to access the image portion of stb. Since it's a header-only function, we don't want to load in everything, but we want to make sure we load in the stb image implementation. So we'll define that there. And we're also going to include stb image.h. And then I guess we'll probably need IOStream for error handling, so let's go ahead and include that as well. So now let's do a few different things. Let's go ahead and I'm just going to copy and paste some of this stuff here. So this is our big function that handles all of our different wraps, internal format, filter, min, max, mag, what have you. And the only thing that we are not implementing is generating our texture ID, and let's just do that right here. So gl gen textures, and we're going to be generating one, and that texture location is going to be at ID. So let's go ahead and do that with a reference to ID right there. And then the other few constructors and our deconstructor are pretty self-explanatory. I'm just going to copy and paste those in. This one is just using format if we don't want to really care about, wrapping. GL repeat and GL nearest are generally the best I've found for pixelated projects, like the project we're going to be working on today. So, and then as I said before, the default standard is going to be RGBA, as in we're going to be working with files that contain transparency both internally and externally. And then our deconstructor is just going to be deleting the textures that we created with our constructor. So that is handled all well and good there. Now let's go ahead and implement our load function. So let's go ahead to texture. Oh, I did not actually create those. We're going to be needing to create our load and bind functions. So let's go ahead and do that here. So void load, and then const gl char star, and this is going to be the text file path. And then that's pretty self-explanatory, and then we're going to need to bind it. So what bind does is it just brings that image to the top of the graphics card so that it knows that we're going to be drawing using that image. And that will come up pretty soon, what exactly that does. But for now, let's go ahead and implement these. Let's go ahead and create a definition here, create a definition, and let's create the necessary files to get this done. So to start off with, we're going to need to store width, height, and NR channels. This is just because SB image requires this, so we'll just go ahead and define those. And another thing that we're going to need to do, at least for now, is we're going to have to set the flip vertically on load. So images in STB, how GL loads images, they load them upside down. I think it's just quicker that way. So they start on the bottom half and then work around to the top half. I don't exactly know why that's the case, but it just is. So we're going to flip it vertically whenever we load the image, just so we can see our guy not be upside down in our image. Now the next thing that we're going to need to do is go ahead and define auto image, and that is going to be STBI image load, or STBI load, I think is the name, the file name. So text file path, X and Y, so that's going to be our width and height. So let's go ahead and do that here. Do I need to, yes, I need to create a reference to width and a reference to height. And then our comp, which is our NR channels, we'll set up here. I don't know if we actually use NR channels, but we need to put something there. And then what do I need for this? The requirement channels, so what channels we're going to be loading it on, we're going to be using alpha. So SBI RGB alpha. So RGBA for the requirements for loading. I mean, we could change this so it's a bit different if you want to load in just RGB, but for our images, they're all going to be alpha, so it doesn't really matter. Then we have to check to see if image loaded properly. So if image, or if not image, because image is fails if it's 0. We'll go ahead and see error here, and then failed to load texture. Oh, and then I guess we'll also put the file path. So fp is equal to text file path, just so we have access to that as well. And then let's throw. I think I've been exiting out of my program for the last episode, but since this is going to be largely a debug application, let's go ahead and actually use throw instead of exit, just so we have a better idea of what's going on. We'll go ahead, throw. Although I guess in shader it's not really going to be necessary or going to be that useful, but at least in this image file, it might actually. We might actually gain a bit more information into why exactly our image is erroring. All right, so after we set up everything, let's go ahead and set up our width and height here. So width is going to be equal to width, and this dot height is going to be equal to height here. And the next thing we're going to be needing to do is using all of our different parameters here. We're going to have to figure out, we're going to have to set those in GL here. So GL bind texture. So this is going to bind our texture to the front of our of our path here. So let's go ahead and call texture 2D since we're going to be using a 2D texture. And then the texture in question is located at ID. So go ahead and call it like this. Oh. Texture is all caps like that. Then we have to set up a bunch of parameters. So to do that, GL text parameter, if I can spell correctly. And they're all going to be i's, so they're all going to be integers. So we're going to be setting up, again, texture 2D. Then we're going to be implementing GL texture wrap S. So how it's going to be handling wrapping, it's going to be this dot wrap S. And we're going to be doing that for every single one of these formatting. So this is going to be wrap T, and this dot wrap T for that. And then this is going to be the filters. So filter mag and min. Filter min. And that's min filter. And mag filter. So this is what it stands for is minimize and magnify, I think. So when it scales up and scales down, we're going to be using GL nearest for both. And that just gives it a better pixelated feel. So like if we're scaling pixels, it looks generally a bit better if you use GL nearest. Of course, if you're trying to, you can look up the different filter options for that in OpenGL, and there's a bunch of different ones you can try out, find out what's best fit for your video game. So now we have to actually create the texture, so we're going to be using the function glText image 2D. So this is creating the texture in our graphics card, or at least giving reference to it. So let's go ahead and create this texture using texture 2D again, and the level is going to be 0. So that means you can have like stacked images on top of each other, and for our program we're going to have just single stacked images at all times. We're not going to be dealing with that, although they can improve performance. We're using a pretty like dinky RPG, so it's not really a huge deal. So our format, or the image format internally, how we're going to be dealing with it, so RGBA, and then the width and height. So let's go ahead and input that, dot height. And then what we're going to be dealing with our border, we're going to have no border. That is just fine. And then our format, so this is what is going to be what the image format is going to be looking like. And then the type, what is the type? Let me look. Unsigned byte, it looks like. GL unsigned. I guess this is defining how it's going to look like on our graphics card, what kind of bytes are going to be using that up. And then lastly, we have to input our image data. So we loaded it with STB here. Everything went smoothly, and then we're loading it to OpenGL now. All right, so we have our image now loaded into OpenGL. The only thing we need left to do is bind it. So we are currently using that image. So to do that, we call bind texture and GL texture 2D, and where we're going to be binding it is to the 0th, I guess to 0. Oh, this is unbinding it. So we bound the texture here. So we bound the texture to our ID here, did a bunch of stuff on it, and then we're now unbinding it. And then finally, we need to free the image using stbi image free. So this is to get all of the work we did with stbi, loading the image from file. Now we have to make sure we're deleting it because this is C++ and memory management. So let's go ahead and call that free the image. And then let's go ahead and deal with bind. So let's go ahead and just figure this out here. So active texture, GL texture 0. So we'll be talking about this in the future, but these are the different text units. So each texture can be stored on a different text unit, and I don't remember the exact number, but there's like a finite number of textures that you can have loaded in your graphics card at one time. But it's pretty hard to reach that limit, and there's no way in heck we're going to do that. But so we're going to bind wherever we're loading our texture onto, or we're going to say that we're on this active text unit here, and then we're going to bind our texture to that text unit. So we're going to call GL bind texture and GL texture 2D, and then our texture ID. So we'll just do ID underscore. And that pretty much means, or makes it so we can use this texture whenever we're doing a render call. So we'll go over and into that in the next episode. But for now, let's go ahead and see if we can load in our texture. We don't actually have a texture, so let's go ahead and see if we can find something here. Let me go to my GitHub. And to my tutorial project. Let me see if I still have the image here. I might have deleted it. I did. I actually have the release here. I'll have a link in the description to find this image. But let me go ahead and just download or move over this image here so we can use it in our project. So you can download the image in the description below, or you can just use your own. It doesn't really matter. It will figure out the width and height and everything properly, so you don't have to worry too much about it. But I'm going to load in this image. So let's go and create a new folder in our resources folder here. Call this images. And we're going to load this little flesh guy here. So flesh guy full 1. And just to see if everything is working correctly. So let's go ahead, include our texture .h, and we're going to texture dot, whoops, well, need to define it first. So let's go ahead and define texture, and then texture dot load. Texture.load, and we're going to need a file path. So let's go ahead and define the file path above it. Const auto image file path, and of we go to a folder here, go ahead and copy the name here. So we'll go to resources/images now, and then we're going to do flash file child full.png. Then we'll load that image right here. And then we'll also call texture.bind, even though we're not going to be dealing with that. This isn't really going to be doing anything besides loading our image. And we had no errors, so we were able to load an image properly. The next step is to create our rectangle that's going to go in the center of the screen, as well as updating the necessary render calls in order to make this work. But for this particular video, that's probably going to do it. In the next one, we're going to go ahead, wrap this up, finish up, and have an image displayed on our window. So thank you so much for watching, and I'll see you guys later.